And now for part 2 of lesson 8.1, we've got an example involving potato consumption. Before I show you that, I'm just going to go through this little strategy that they put in the book for how to solve modeling type equations with integrals. Approximate what you, number one, approximate what you want to find as a Riemann sum of values of a continuous function. So basically you set up the Riemann sum first, and then you can write that as a definite integral, because we have the sum of a whole bunch of values with respect to the subinterval length delta x. So if we're adding up a whole bunch of little tiny slivers of something, we can turn that into an integral. So that's basically what an integral means anyway. So once you write the integral, we know how to solve those probably a little bit better than we can complicated summation Riemann sums. And then we will find the limit of that as the partition goes to 0, which is evaluating the integral. And you can use antiderivatives to evaluate those. So here's our example. We've got the rate of potato consumption in a particular country from 1970 to 1980, and it was calculated in this little exponential formula here in millions of bushels per year, T being years since the beginning of 1970. So think about that like January 1, 1970. How many bushels were consumed from the beginning of 1972 to the end of 1975? So since this function is valid for 1970 to 1980, then when t equals 0 is 1970. What are my values of t that I would want to use? Since I'm talking about the beginning of 1972, I would start at 2. But I want to go all the way to the end of 1975, so be very careful of that. It is not 5, because that would be the beginning of 1975. So if I want to go to the end of 1975, we would be talking about basically the beginning of 1976. So we're looking from years 2 to 6. Now, I'm going to show you how to, I would probably just go straight to the integral. I know that I want to calculate an integral from 2 to 6 of c of t dt. And pretty much that's all we need to do. Because this is a little bit more complicated, I could probably find the antiderivative of it, but we have calculators that can also do that. So for this problem, let's just use our calculator to evaluate this integral. So you can pause this video at any time and type it in. Remember, where you would do that is with the fnint button, which is under math number 9, and then you put your values in. If you have one of the older calculators, you have to type in the function. Oops, not that. Undo, comma. It's not undoing it. Oh, it is. Okay. Comma. And then you have to put the variable and the starting value and the stopping value, and then it will evaluate for you. So when you plug that in your calculator, you should get 14 point, remember this is calculus, we go to 3 decimal places unless they tell us otherwise, so 14.692 million bushels. So not a super hard problem. Now let me show you how they explained to do this, because they're going to explain the Riemann sum part a little bit more first. So we know we're going from 2 to 6. Here we go. Step 1, we're going to partition 2 to 6 into subintervals of length delta t. So we're cutting it into little slices. And let t sub k be a time in the kth subinterval. The amount consumed during this interval is c sub t k, c of t sub k times delta t, because we're multiplying like little rectangles, million bushels. So the consumption from time 2 to 6 is the sum of all those. So basically you could take each little subinterval and figure out how many million bushels were being consumed, multiply it by the width of that rectangle, and then add up all those rectangles, and we would get it. But that's exactly the same thing as doing the interval from 2 to 6 of c of t dt. So that what we did to solve this problem was a little bit easier than what they did. That ends our potato consumption example. See you soon.